A vertex V postdominates a vertex U if V is on every path from U to exit. And it strictly postdominates U if it postdominates U and V are different. So in this case, we can see that V does not postdominate U, since U is not on every path. Sorry, V is not on every path from U to exit, since we can go in this direction instead. W postdominates X and Y, since, well, we must go through W if we want to go to exit. How can we compute postdominance? We can use the Langer-Artarian algorithm and the reverse control flow graph. The reverse control flow graph is the control flow graph with every edge reversed. We will now see a definition of control dependence, which is useful for finding out which conditional branches should be marked as live during the dead code elimination algorithm. So we can make this a little bit simpler, first by removing strictly there. And first, a non-null path is a path with at least one edge. Okay, and let's say a vertex V is control dependent on a vertex U, as in this case, if there is a non-null path from U to V and V postdominates every vertex on the path after U, and V does not postdominate U. Okay, let's see if this works. On this path, well, we start with the vertex after U, so it will actually be V, and V postdominates itself. So this one is fulfilled. And then the second, V does not postdominate U. Well, it does not. And now we can see that, okay, if we want the V to be control dependent on U, then this definition works for V and U. In the same way, clearly, X is control dependent on U. Well, it's basically the same thing as V, but Y is not control dependent on U. Why? Well, let's say, first, Y does not postdominate U. It does not, since we can go from U to E without passing Y. So that the criterion is satisfied, and what is not satisfied is that there exists a non-null path from U. We can take this path from U to Y, such that every vertex on this path after U is postdominated by Y. Well, it's not. Since, well, if we take this path, we could take another path, but we just observe one path at a time. And Y postdominates itself, but it does not postdominate V, since we can go from V to E without passing Y. Okay. So we can skip that one, but if we take W instead, then W does not postdominate U, since we can go there, and there is no way, if we go from a successor, I mean to this successor, from U and then to W, that we will not end up in W. What does that mean? It means that, okay, let's be concrete first. If we look at this, there is a non-null path from U to W, and W post-dominates every vertex on that path after U. That means X and W. Okay, what does that mean really? It means that there is no way to go from this successor, I mean the first vertex on the path after U, without going through W. In practical terms, that means U decides that W will be executed another time. I mean, it can decide that. It can decide that it will not as well, but it can decide that we eventually will come to W. That means that conditional branch is essential to make the program work. So we must mark that one as live. Okay. If we now look at this one, which nodes decide that the W will be executed another time? Well, we just, sorry, not decide, but, well, can decide that it will be executed another time. Okay, so it was U, and as we discussed earlier, we also saw that it was V. Okay, let's check this out using the definition. So there is a non-null path from V to W, and W post-dominates every vertex on that path after V. Okay, so the first vertex on that path after V is Y, and W clearly post-dominates Y. Okay, and it post-dominates itself as well. And W does not post-dominate V, which means there is an opportunity to go from V to exit without going through W, so that V controls whether W certainly will be executed if we go in that direction, or it may not be executed. So, and in that case, it will certainly not be executed. But for you, it can decide that it can certainly be executed if we go there, but it does not decide if we go in the other direction that it certainly will not be executed. It just may or may not, but if we go in that direction, it certainly will. Okay, so W can also decide that it will be executed. Namely, if we are in W, we can decide to go back to W. And therefore, we need this strictly in the definition. Okay, so the set of vertices which are control dependent on U is denoted like this, and those which V are control dependent on is the inverse.